End-to-end, E2E, testing is a comprehensive testing approach that validates the entire software application flow, from start to finish, to ensure that the system behaves as expected in a real-world scenario. It involves testing the complete application environment, including all integrated components, external systems, and interfaces, simulating real user behavior. Key aspects of E2E testing. Objective: to verify that the application's workflows function correctly across different modules, and that the system works seamlessly with external interfaces like databases, APIs, and third-party services. Scope: covers all critical paths in the system, including user interactions, backend processing, data integrity, and overall application stability. Focus: tests the application from the user's perspective, ensuring that the entire workflow operates as intended. When to perform E2E testing. After major updates or enhancements to ensure overall application stability. When new features are introduced that affect multiple modules. Prior to releases to validate that all components work together harmoniously. To ensure complex user journeys or workflows are correctly implemented. Types of E2E testing. User interface, UI, testing, validates the user interactions with the application, including button clicks, form submissions, and navigation flows. API testing, tests the integration between different software components using APIs, ensuring that data flows correctly and responses are accurate. Database testing, ensures that the application interacts correctly with the database, including reading, writing, updating, and deleting data. Integration testing, verifies the proper communication and data exchange between all integrated components, including third-party services. Steps in E2E testing. Requirement analysis, identify critical end-to-end workflows based on user requirements and business needs. Test planning, develop a strategy for testing the complete flow, including selecting the right tools, defining test environments, and identifying key scenarios. Test case design, write detailed test cases that cover all steps of the workflow, including setup, execution, and expected outcomes. Test environment setup, set up the test environment to mimic the production environment as closely as possible, including configurations, databases, and third-party integrations. Test execution, run the E2E tests and observe the behavior of the application, logging results, and any failures. Defect reporting, document and report any issues found during testing to the development team for resolution. Test closure, validate defect fixes, update test cases if necessary, and ensure all critical paths are covered. Tools for E2E testing. Cypress, a popular modern tool for front-end testing, ideal for E2E tests involving UI interactions. Selenium, widely used for automating browser interactions and can handle complex workflows. Playwright, provides cross-browser automation for web applications with powerful debugging capabilities. Postman/Newman, for automating API E2E tests, verifying the flow between different services. Robot Framework, an open-source automation framework with keyword-driven testing capabilities, suitable for complex E2E tests. Best practices for E2E testing. Prioritize critical paths, focus on the most frequently used and business-critical workflows first. Maintain realistic scenarios, use real-world data and user scenarios to test the application. Automate where possible, automate repetitive E2E tests to ensure consistency and save time. Isolate test data, use clean, predictable data for testing to ensure reliability and repeatability of tests. Continuous integration, integrate E2E tests into the CI/CD pipeline to catch issues early and ensure the application is always functioning as expected. Example of E2E testing using Cypress, JavaScript. Here's a sample E2E test scenario using Cypress to validate a user login and navigation flow in a web application. //cypress/e2e/test_e2e_spec.sci.js. Describe, end-to-end test for user login and navigation, equals. Before each, equals. / setup actions before each test. Sci.visit, https://example.com//replace with your application URL. It should allow a user to log in and navigate to the dashboard, equals. / locate and interact with the login fields. Sci.get, #username, .type, valid_user. Sci.get, #password, .type, valid_password. Sci.get, #login button, .click. / verify login by checking for a specific element on the dashboard. Sci.url, .should, include, /dashboard. Sci.get, .welcome message, .should, contain, welcome, valid_user. / test navigation to another section. Sci.get, #profile link, .click. Sci.url, .should, include, /profile. Sci.get, h1, .should, contain, user profile. It should handle invalid login attempts gracefully, equals. / attempt login with invalid credentials. Sci.get, #username, .type, invalid_user. Sci.get, #password, .type, invalid_password. Sci.get, #login button, .click. / verify that the error message is displayed. Sci.get, .error message, .should, be .visible, .end, contain, invalid credentials. Explanation. Setup. The before each hook sets the starting state by visiting the application's URL. Test valid login simulates a user logging in with valid credentials, navigating to the dashboard, and then to the profile page. Test invalid login verifies that the system handles incorrect credentials gracefully by displaying an error message. This approach provides a comprehensive test of critical user flows, ensuring that the application works as intended from the user's perspective.